All right, let's start this off with Jade. Jade, if I'm going 25 miles an hour, what is that in kilometers per hour? And how did you get that? What did you do with the 25? And what did you get? You said 40.2? We'll call it kilometers per hour like that. Okay. Cool. All right, let's go to Brian. How'd you get what 40 miles per hour was in kilometers per hour? What'd that give you?
64.3.
You guys agree with that?
Well, 64.37, you could round it up to 64.
All right, I'm not too worried on that one, but that's true. Okay, so about 64 miles an hour. Awesome. Okay, Isaac, will you take 65?
Yeah. Use 65 times 4.6. 934. You get one part. The original is 104, but I just rounded it to 105.
What is it? 104 point what?
0.60.
All right, we'll call that good. So I remember, so I was actually in South Africa, and they use kilometers per hour. And I remember getting on the freeway, and it was like, speed limit's 110. And I was like, yeah, 110. And then it was like only going like 60 or 65. I was like, this isn't nearly as cool as I thought it would be. Because then like miles per hour, 100, we're like, yeah, but.
Triple digits should be special, and these conversions
Right.
make them not special.
All right, now, what's the whole point of this, guys? Well, we're talking about speed here and how you can measure speed in different ways. You can measure it in miles per hour, kilometers per hour. And if you're trying to convert them, you just need to know what to times it by. Now, let's work backwards here. What if I gave you something in kilometers per hour? How would you get it into miles per hour?
The opposite,
Which would be what?
dividing it.
Dividing it by that 1.60934. The reason why I started with that is because today we're going to talk about different ways to measure angles. We've talked about angles in degrees, and today we're going to talk about angles in radians. And how we can convert, and we just need to know what to times it by. All right? So kind of summarize, what were the two ways we measured speed?
Miles per hour and kilometers per hour.
And then kilometers per hour.
Kilometers/hour.
Okay, now when we're talking about angles, we're really used to measuring angles in which way? Degrees, which in degrees, we say one rotation is 360 degrees, and then we can break down other ones by being less than that or whatever, okay?
What's the other way?
The other one is going to be called radians. Have any of you guys ever talked about measuring angles in radians before?
Like radians of the sun.
You have, Isaac? Anyone else?
I mean, I probably.
So it's kind of an abstract way of thinking about it, but I'm going to try to do an activity with you that's going to make sense of it. One of these days, I'm going to write a song about it. It's going to be called Arabian Nights. Get it? Like Aladdin? Okay, that's it. Now, central angles and arcs. This is just kind of some vocab. Because when we're going to make a radian, it's going to be a central angle with a certain arc length. Now, a central angle is basically what I'm going to do is I'm going to draw an angle on a circle where the vertex of the angle is the center of a circle. Now, when I do this, notice that it makes an arc right here. And that arc could be bigger if I make the angle bigger. It could be smaller if I make the angle smaller. Okay? Now, one thing that's important to notice here is that on the angle, both of these sides are described by the letter R. What does the R stand for? Radius.
Which is
So when I make an angle, it will be, the length will be a radius. Now, what I'm going to do, guys, is I'm going to make what's called a radian. A radian is made when this length right here is also going to be r. So whatever the radius is, if I take this length here and I make it so the arc is that same length, then you've created a radian.
So radians can only be specific angles?
Yes, a radian is a specific angle. So let me show you again. Let me just kind of draw this out. I'm going to use technology to draw a circle because circles are actually pretty hard to draw.
Yeah, I didn't think that in class. I was drawing circles and I did a thing to draw it for me and I'm like, oh man, my circle was trash.
Yes. So guys, if I take this circle right here, and I'm going to measure this length right here, what letter do we call this?
R.
R, because it's a radius. Now if I were to measure that, and measure this right here and say, hey, I'm going to measure the same length here, this angle that I've created is called a radian. And it's the angle measure where this arc here, this intercepted arc, is the same length as the radius.
Is there only one? Could you do like a double one?
Well, now here's the question that we're going to answer. How many radians fit into one circle? Or in one revolution? And it doesn't depend on how big.
Is it?
No matter how small the circle is or how big, it will be the same. And to answer that question,
A diameter?
no, we're going to do it. We're going to do an activity here. But as we're going through this activity, what you're going to think in your brain is how many radians fit in a circle. Now, I'm going to demonstrate how you're going to do this activity, and then you're going to partner up and do the activity. All right? So what I'm going to do. Sorry, I'm just getting situated here. Is I am going to have a piece of paper. And does anyone know what this pokey thing is here?
No.
Not a protractor.
I was gonna say
Draw
something.
circles?
I know.
It's a circle drawer, also called a compass.
There we go. I
Oh.
was like, I hit something too.
Who has used a compass before?
I've used a
I've used one.
This is a circle drawer, okay? Because
circle
drawing
drawer.
circles by hand is hard, so use a compass. What we're going to do is we are going to take a paper and we're going to draw a circle. And I don't care how big it is as long as it fits on here. So you can make it small, you can make it medium or big, whatever. Just make sure it fits, and I'll show you the best way to do this. And what you're going to do is we're going to use what's called a wiki stick. It's kind of like a sticky rope. And we're going to measure the radius, and we're going to copy it down so we make a radian. And then we're going to repeat this and see how many radians fit on a circle. All right? Now let me model how we're going to do this first, and then you're going to do it on your own. I'm just going to show you how to do the first one. So let me pull up my camera so you can see what I'm doing.
Is it 6?
It is not 6. That's a good guess.
Is it?
Just visualizing. No guessing. You're just going to do the activity. You're kind of spoiling.
She got details.
I was too close. No, my guess was almost there. It's obviously like 5.35.
Okay, so guys, what I'm going to do is first off, I'm going to label where I think the center is. Okay? And it doesn't have to be perfect. I'm going to go right here. And I'm going to adjust the length or the height or the width of this to where I think is good. Now, I want to make sure it fits. Oh, can you
You're
even see what I'm
blurry.
doing?
I couldn't see your dot, your middle point.
There
Okay.
we go.
Now, here's a trick. When you're doing this, it helps if you have paper underneath. And then the other trick is it's easier to just hold this still and rotate the paper. You just got to make sure things aren't in the way.
My goodness, we need to sharpen the pencil on there. That's so good. The sound is like,
All right. And look, that matched up so perfect. And I just made a circle. Okay, now that I've made a circle, what I'm going to do is I'm going to draw a radius. So I'm going to get you guys are going to use a ruler. I'm just going to use a piece of paper here. I'm just going to draw from here to the edge. And it doesn't matter where I do this because no matter where I do it, it's going to make a radius, right? That's a property of a circle. Now this length right here is called a radius. Now what I'm going to do is I'm going to take this is called a wiki stick. It's basically like a string, and it's covered in wax, so it sticks. So what I'm going to do is I'm going to make sure this is the length of a radius. So I'm going to lay it down here, make sure one end is on the center, and where it intersects with the circle, I'm going to put a little thumbnail print. Okay? And I'm going to take some scissors, and I have special scissors for this because it gums it up, and I'm going to cut that off. So that this wiki stick is now the length of the radius. Now, how do we create a radian? What did I say you need to do? We're going to make the arc length also the length of a radius. So I'm going to come and lay that down right there, and I'm going to put a mark where that ended. And then I'm going to take the radius off because it's hard to get on there with the ruler. And I'm going to measure from here to here. I'm going to draw that. And what I have is, what is this right here? 1 radian. It's an angle created by mapping the radius onto here. Okay, now I'm going to pause right there. What you guys are going to do is you are going to keep it going. You are going to measure again and again and again, and see, and try to be as accurate as you can, and see how many radians fit in 1 revolution.